You see, our universe is kind of like a finely tuned machine.
Scientists have found that there are about 20 numbers, 20 fundamental constants of nature that give the universe the characteristics we see today.
These are numbers like how much an electron weighs, the strength of gravity, the electromagnetic force, and the strong and weak forces. Now, as long as we set the dials on our universe machine to precisely the right values for each of these 20 numbers, the machine produces the universe we know and love.
But if we change the numbers by adjusting the settings on this machine even a little bit, the consequences are dramatic. For example, if I increase the strength of the electromagnetic force, atoms repel one another more strongly, so the nuclear furnaces that make stars shine break down. The stars, including our sun, fizzle out, and the universe as we know it disappears.
The laws of physics could have been very different. You could imagine a world that didn't have electrons in it. There's nothing wrong with that in the basic theory of the mathematical theory of physics. You could just throw away the electron. What would happen if you threw away the electron?
No chemistry.
No atoms, no chemistry, no biology, no people to ask the question.
Right.
We just wouldn't be here to ask the question. You could change the rules in other ways. You could make gravity stronger. Gravity is very, very weak. You know, normal people think gravity is very strong. When I wake up in the morning, especially the older I get, the harder it is to get out of bed.
Yeah.
So I think, oh boy, wouldn't it be nice if there wasn't much gravity? Well, in fact, gravity really is very, very weak. If you were to compare in an atom the gravitational force between the electrons and protons compared to the electrical force, the gravitational force is completely negligible. Right? Why is gravity so much weaker than the other forces? Well, we don't really know, but here's what we do know. If it were just even a little bit stronger, stars would burn out too quickly, they wouldn't live long enough for life to evolve. Instead of stars, instead of galaxies, we'd have black holes. We can't live in a black hole. I mean, science fiction, maybe you can live in a black hole, but we can't really. Most likely the universe would expand and contract too rapidly. And so everything seems to be almost on a knife edge, that if you were to change the rules of physics, the laws of physics, even a little bit, the world as we know it wouldn't exist.
Let's talk about one of them, though, that has some particular strangeness to it, the so-called cosmological concept.
That's right. That's the one which is really on a knife edge. Okay? It is on such a narrow knife edge that it's almost inconceivable. If you were to change it just the tiniest, tiniest bit, we couldn't be here. This cosmological constant is it's almost a kind of anti-gravity. It's a kind of repulsive force that's implicit in Einstein's equations for general relativity. It could be there. Physicists had every reason, theoretical reason, not experimental reason, theoretical reason to think that the world should have this kind of anti-gravity. Anti-gravity would cause everything to separate at an enormous rate, repulsion. The actual magnitude of it is incredibly small. So the dark energy is not exactly zero, but the first 122 decimal points are zero. That's crazy. That is really one of the craziest things we've ever discovered.
The amount of it is bizarre. It's a number that has basically a decimal point, 122 zeros, and something like a 138 at the end. It's hard for us to imagine starting with a theory, doing calculations, and after some number of pages of scribbling, having 0.00000, all these zeros, and then a 1 pop out of our equations.
The size of the dark energy determines how fast the universe expands.
Now, the important point is here, it could have been anything. It could have varied anywhere from some gigantic explosive tendency to expand to some gigantic explosive tendency to collapse. Why it came out after everything was settled in this very, very tiny range which allows the world to have expanded at not too fast a rate, we honestly don't know.
But one thing we do know is that intelligent life probably couldn't exist in the universe if dark energy wasn't just how it is. Another fine-tuning is the famous Higgs boson, recently discovered in the atom smasher at CERN. It's dubbed the God particle because it gives substance to all nature's other particles. But it too is just right so that we can exist.
If the Higgs boson were not also finely balanced in a similar way to the way the dark energy is, that would be very dangerous because it would in effect mean that gravity was much stronger. So the Earth would probably collapse into a black hole.
And there are many other fine-tunings, from the value of the speed of light to the charge on the electron.
Okay, we have fine-tuning. We've got to deal with it. Now, there are a number of ways that we can explain that. I mean, it cries out for explanation.
Yes.
We cannot say, oh, yes, fine, and let's go on. We have to explain it one way or another.
Basically, there are three explanations.
Okay, number one.
Okay, God.
Number two. that one I understand.
Right. Accident.
Okay,
Right,
that
the
strains
picture being-
credulity just
Right.
by
It
on its
strains
face
credulity.
value.
Right.
So it's an
Right.
accident just that way, and it happens to work out perfectly.
For example, the size of the moon in the sky is exactly the same as the size of the sun in the sky. That's why solar eclipses are so interesting, because you can see the atmosphere of the sun. Why is that true?
It's because of a remarkable matchup. The sun is 400 times wider than the moon, but it's also 400 times further away, making it appear the same size as the moon.
So it's useful for people who study the sun, but the reason that the moon and the sun are the same size in the sky is not so that astronomers could study the sun. It just happens to be a fluke.
That's a fine-tuning that there's not going to be any explanation for.
So, could the other fine-tunings be flukes too? Well, actually, the sun-moon match is not that accurate, only to 2 decimal places.
To 2 decimal places is not that crazy. What's crazy is to think a thing is a fluke if it's 123 decimal places.
To write the fine-tunings off as merely coincidences seems far-fetched.
Look, if I see my kid eating a chocolate chip cookie and my kid said, oh, the cookie jar fell over and the cookie fell into my hand, will I believe that, or do I believe he stuck his hand in and grabbed the cookie? I believe the latter because the former explanation is so fine-tuned. The cookie jar would have to fall over at the right moment. His hand would have to be there just to catch it. That just seems unbelievable.
Some take fine-tuning as evidence that God created the universe.
I think somebody who looks at the universe and thinks it's been fine-tuned for us needs a good lesson in humility. We are these entities that the universe, I don't think, really cares all that much about. To think about the universe, this massive, enormous, expansive space with incredible number of stars and planets, for us, these little puny creatures?
It's also incredibly inhospitable. If you were designing a universe for life, I suspect you might design it differently. There is no evidence of design or purpose to our universe.
Well, the question is God the best explanation for the existence of human life or anything else? Or do you have some other explanation?
There is another explanation some have suggested. God didn't create the universe. Aliens did. We puny Earthlings are only capable of crude virtual reality at present. But alien VR could be much more sophisticated. We might be living in one of their virtual simulations without even knowing it.
If we could create a virtual world that was so sophisticated that it couldn't be differentiated from the real world, what's the difference? And the answer is, there is no difference. And so it's possible that we're a simulation on someone's computer.
It's possible, but scientists put that one in the too hard basket.
What does it matter? What does it matter if the origin of our universe was inflation, the Big Bang, or a kid in his garage? We still have life as we know it. I've still got my wife and my kids. It's fun. I'm just going to live it as if it were real, and in some sense it doesn't matter where it came from.
The only explanation I know, and I think it's fair to say the only explanation that's out there, is that There are many, many possibilities for this number.
In other words, we live in a multiverse, a vast region made up of many, many universes where ours is just one of them. And each universe has a different value of dark energy.
We think that the universe we see is all there is, but it's very possible that there's literally other universes. They could be disconnected from ours, or they could just be very, very far away, and they could be the same laws of physics, but different cosmological conditions, or they could be even radically different laws of physics, different numbers of dimensions of space, different kinds of particles and forces.
So everything that seems fine-tuned in our universe could have different values in the other universes.
And if that's true, then there's a selection effect, that we are only ever going to find ourselves in the parts of this multiverse that are hospitable to human beings coming into existence.
Think of it like this. The Earth seems finely tuned so we can exist. It's the perfect distance from the sun for mild temperatures and liquid water. It has a protective giant Jupiter nearby to keep rogue asteroids from hitting us. All key requirements for intelligent life to evolve. But the Earth's not fine-tuned. The galaxy is teeming with at least 100 billion planets. By chance alone, there'll be at least one fit for intelligent life. In a multiverse teeming with universes, there'll be at least one that's suited to us.
You know, if you go to the shop and you want to get a nice suit, are you surprised when they have your size? Well, you would be if there was one suit and it just happened to fit. But if they've got a rack of every possible size, it's no surprise that they have one that fits you. If there are many, many universes with many, many different features, then it's no surprise that there's one that would fit us.
The big problem with the multiverse is that we're trying to say, well, we can't explain this universe as we see it. We'll appeal to some bigger system which we really can't observe.
The fourth way is, who knows, maybe someday somebody will figure it out.
Oh, sure. There is one ultimate solution. All of these constants of nature can be devolved
maybe
down
somebody will figure
to a fundamental equation that
some
will
fundamental
express all of these as derived functions.
But that would partly fall into the category of accident. You take some fundamental equation and you solve it. It would take an incredible accident for it to have a solution which was all that small.